Okay, good morning and welcome to our uh, review of functions for Math 8. So today we're going to review functions and we're going to talk a little bit more about how to determine whether something is a function, whether a relation is a function or not. So if you have the notes with you or have the worksheet that I'm handing out in class today, it says functions 1 on it and section 1. So you might want to pause the video here so that you can write down the definitions that are important for our lesson today. And those definitions are function, input values, and output values. So let me remind you that a function is a relation where each input value, or x value, is assigned exactly one unique output, or y value. And so then I wrote that down. Input values are x values and output values are y values. For example, if you have the ordered pair 2, 4, your input value is your x value of 2 and your output value would be 4. That's your y value. Okay, so that, if you need to, again, pause the video to write down the definitions. What we're going to focus on today is how to determine whether or not something is a function, a relation is a function, by looking at ordered pairs, graphs, and by a description. So we're going to start with ordered pairs. And if you're in my class, we've done this before, but let's review, okay? So the first relation we're going to look at is relation A. And to determine whether or not it's a function, we are going to make what we call a arrow diagram or mapping diagram. So what we're going to do is this. We're going to separate our domain, which is our x values, and our range. So this is section A. So remember that your domain is your x values, and those are all our first values. So this one, okay? So 2, 3, 4, and 5. So we'll write that down. 2, 3, 4, and 5 is our domain. Now remember, if there were repeats, we wouldn't write them twice. Our range now is going to be our y values. That's our second ones. Y is all the second values. So in this case, 3, 4, 5, and 6. And what you do is you make the arrow diagram to determine whether or not it's a function. So the arrows look like this. So 2 maps to 3, and you make an arrow. 3 maps to 4. 4 maps to 5. And 5 maps to 6, okay? And what you're looking at is just the domain side. If the x's all have exactly one arrow coming out of them, we say, yes, this is a function. If there were more than one, then we would say, no, it is not a function. So let's do it one more time. And then I'm going to leave C for you to do on your own. So on Part B, let's do the same thing. Separate a section for Part B, and let's do our domain. So our domain, remember, are our x values. So x is the first one. So we have a 0, a 1, a 0, and a 2. So a 0, a 1, the second 0, we already wrote that down, so we don't write it again, and then we write 2. Our y values are our second one. So we have a 0, a 3, a 4, and a 5. A 0, a 3, a 4, and a 5. And then we do our arrow diagram. So the first one says 0 maps with zeros. The second one says 1 maps to 3. 0 maps to 4. And 2 maps to 5. Okay, again, we're only looking at the domain side here now. So here's our domain side. And we're looking to see, is there exactly one arrow coming out of each one? And right away, there are 2 arrows coming out of the 0. So this means this is no, this is not a function. Okay, and that's how we determine if a relation is a function from ordered pairs. Okay, let's move on to something new. So something we haven't talked about yet is how to determine whether something's a function on a graph. And really, it is the same exact thing. So up here, something to show you is that on a graph, 0, 0, and 0, 4 would land on the same line. So I'm going to make a little graph next to this just to kind of show you. And it's going to be a miniature one. So for part B, the graph of that would look something like this. And so we can make a little miniature graph. A 5 by 5 is all you need. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So if we were to draw this graph and put all these ordered pairs on, 0, 0 is right in the middle. 1, 3 would be right 1 and up 3. There's that dot. 0, 4 would be left and right 0 and then just up 4. Okay. And then 2, 5 would be right 2 and up 5. Now, in a second, I'm going to show you the vertical line test. But what we're trying to say is the reason this wasn't a function is that 0 mapped to 0 and 0 also mapped to 4. And the vertical line test, you can do that by looking at a graph. If I drop a vertical line on this, there are 2 dots on one line. Whereas if I were to map out all these, there would only be 1 dot on every vertical line. Okay, so let's look down below. You might again have to pause the video to write the definition, but a vertical line test says that any vertical line may not pass through a graph more than once to be a function. So what this means on the graph, if I look at this first one, I can drop a vertical line on here and it only hits the graph one time. I can drop one over here. Again, it only hits the graph one time. I can drop one in the middle somewhere. Only one hit. There is no spot on this entire graph where I would hit the graphed line in more than one spot on a line. So this, we would say, yes, this is a function. It passes the vertical line test. All right, passes, and we will abbreviate the vertical line test, the VLT, meaning those vertical lines all only have 1 dot. Now, if you look at the next graph, though, okay, I can draw a vertical line over here, and it only hits in one spot. I can draw a vertical line right here, and it only hits in one spot. But if I go over here, a vertical line hits the graph 2 spots on the same line. If at any point there's a vertical line that it hits in more than one spot, we would say no, this is not a function. It fails the vertical line test. Okay? That means that if we were to make the arrow diagram like we did above, how many spaces over this? This is 2, maybe 0.5 and 2, 3. And so we would have 2 arrows coming out of the 2 there. All right, I will leave the last one for you on that section to try. All right, the last section is maybe the most challenging because you have to translate some words into mathematics first of all, and then use it to determine whether or not you have a function. For the sake of the video, we're only going to do part A, and I'll leave part B for you to do on your own. So the first thing you need to do, it says use the description to make a table, then determine whether the description is for a function. Well, in order to do this, you got to translate these words into math. So each output, remember output meant y, so that means this is going to be y. Is equal to, so is equal to means make an equal sign. 3 times, all right? So 3 times the input value. Notice I'm not putting the time sign yet. The input value means x, right? So 3 times x, I can use it just like this, 3x plus 1. Plus would just mean the plus sign and then 1. So this is going to be an equation we're going to use to make a table. So what I'd like you to do is draw a table just like this off to the side, put an x, and then we're going to put our equation in the middle. Y equals 3x plus 1, and then put a y value over there. Now, to make your own table, you get to pick your x values. My advice to you is pick some easy ones, all right? So I'm going to pick 0, 1, and 2 for us, okay? And that is in our x column because we're going to replace x in our equation, okay? So we're going to rewrite this middle as y equals 3x, but we're going to use 0. So 3 times 0 plus 1. And our answer will go over here. 3 times 0 is 0 plus 1 is 1. Okay? And then we're going to do it again. Y equals 3 times, and this time I'm going to replace the x with 1. 1 plus 1. Well, 3 times 1 is 3, plus 1 more would be 4 for our next answer. All right, let's do it again. Y equals 3 times 2 plus 1. 3 times 2 is 6, plus 1 more would be 7. Okay, and now realize that these are going to be ordered pairs. So our ordered pairs would be 0, 1. And then 1, 4. And then 2, 7. Those are ordered pairs just like we saw in section 2 above. And our arrow diagram would look like this. 0, 1, and 4 are our domain values. Our range would be 1, 4, and 7. If we were to do our mapping diagram, 0 maps to 1, 1 maps to 4, 4 maps to 7. Only one arrow comes out of each value of the domain, so yes, this is a function. And that's the lesson today. So if you have me for class, the assignment now is on the other side. It's short, it's only 8 questions, but I copied it right to the other side, and we will have that to be turned in tomorrow. If you have questions, please feel free to email me, and I will get back to you as soon as I possibly can. Hope you all have a great day, and I hope to see you soon.